Alright, so next is we will take a look at the Sugeno style of rule evaluation. Right, so the defuzzification process in Sugeno style is similar, but then when we go into the next phase, that is the rule evaluation, it will be a little bit different. Yeah. So the most commonly used is zero order Sugeno fuzzy model will apply fuzzy rule in the following form. Okay, so the fuzzy rule will be like this: if x is a and y is b, then z is k. K meaning that k is a constant value. So in this case, the output of each fuzzy rule is constant, and when we say that it is constant, it is represented by a singleton spike. So before this, if you can imagine back your Z in Mamdani, you have a graph, right? Okay, a fuzzy graph like this. Okay, but now in Sugeno, it will be in singleton spike like this. Okay. How are we going to define the singleton spike? Okay, it is like this. Okay, before I proceed with how are we going to define on singleton spike, so it will be like this. When you have a fuzzy graph, two input graph. Okay, so this would be Z. Your Z will be in a singleton spike like this. Okay, so how are you going to do or to determine or to define the Z value? You have to use mathematical function of the input variable. Okay, so that is why in here fuzzy relation of Sugeno style is referred as Takagi-Sugeno-Kang model, and basically the Sugeno style fuzzy inference is very similar to the Mamdani method, but then it changed only on a rule consequence here, on a Z value. Okay, so instead of a fuzzy set, so when we say fuzzy set, we have like this lah. Okay, example, we have the fuzzy graph like this. Takagi-Sugeno-Kang will use mathematical function of the input variable, so that is why we are going to have, based on the mathematical function, when we input them, okay, based on the input variable, we are going to have a singleton spike here. Okay, so the format of Sugeno style fuzzy rule is like this. Okay, you have antecedent. If x is a, okay, you have so you still have fuzzy graph for antecedent, okay, for the input, and y is b. Okay, for example, it's like this. Okay, then z is a function. Okay, a mathematical function of x and y. Okay, so x and y are linguistic variable of your input, yeah, and z is linguistic variable as well. So a and b are fuzzy set. Okay, we know that a and b are fuzzy set on universe of discourse x and y respectively, and f x y is a function of z for z. Okay. So the output is a function. Let me just padam yang ni dulu. Erase this one. Sorry. Okay, so the output is a function of one or more input variable, and as developed by Takagi and Sugeno, the output is linear and constant function of the input. Okay, and the method has been extended to non-linear function, but we are going to use the linear. So you are given a rule here: if x1 is small or x2 is low, then y is a function. So this is the mathematical function for your y. So once you have input the value of x1 and value of x2 in your mathematical function here, then you are going to have the spike. Okay, so y for rule 1, for example, y for rule 1 would be 15.5, the value here. Okay, so from there, then only we are going to do the weighted average to calculate the degree of membership. Okay, so the aggregation of the rule output is the same. Okay, Aggregation is a process of unification of all output of all rule. So previously you have seen the aggregation of Mamdani, where you aggregate all of the fuzzy graph that has been clipped into one graph, okay, one aggregation graph. In Sugeno style, you are going to aggregate all of the mathematical function that you have been input with the x and y value from the input variable, okay, and then from here, then only you are going to calculate the weighted average for defuzzification process, okay. So this is similar for aggregation of Takagi Sugeno style, okay. So in defuzzification of Sugeno style, you are going to use weighted average. So previously in Mamdani, you are going to use center of gravity, right? So in Mamdani, you are using the center of gravity. But then in Sugeno style, you are going to use weighted average, okay? So in weighted average, what you have to do is you have to calculate the weight of every what they call that mathematical function here of the degree of membership times the value of the value of your universe of this course times the value of the degree of membership here. Okay, so for example here, this is 20, this is 50, okay, based on here, and this is 80. And the value here is 0 0.1, 0 0.2, 0 0.5. So you are going to calculate the weighted average using 0 0.1 times 20 plus 0 0.2 times 50 plus 0 0.5 times 80 over the total of degree of membership that you have. Okay, so you have 3 universe of this course, you have 3 single spike. Okay, so from each of the 3 single spike, what are the degree of membership? Okay, so you are going to have 65. So 65, okay, will be the Chris input. Okay, so based on previous calculation of our fuzzification, for example, say we have 35% of project funding and 60% of project staffing. So our Chris output based on Sugeno style of rule evaluation, okay, we are going to have 65% of risk. Okay, so this is 35 is funding, and 60% is your staffing. So your risk would be 65% based on our calculation of weighted average in your Sugeno style rule evaluation. Okay, so this is the formula. This is the mathematical formula. Okay, how are you going to calculate the weighted average? So we have discussed it here. Okay, so before we wrap them, okay, let me just show you a simple example of Takagi Sugeno. Okay, I will draw it here. Okay, if you take a look at the question, okay, assume that we have a simple system with 2 rules, 2 input variable and 2 membership functions per input variable. So this is your first input, this is your second input. Okay, so you have 2 input variable here, and then this is your rule. Rule 1, if U1 is S1 low, okay, and U2 is S2 low, okay, rule 1 is low and U2 is low, then Y is a membership, a mathematical function. Okay, y is a mathematical function where this is the value that we are going to incorporate with the value of your input so that we can draw the single spike here. Okay. Rule 2, if S1 is high and S2 is high, then the value of y is another mathematical function and the function. Okay, so now you suppose that u1 is 8. Okay, so this is your input variable, just like we have seen on previous slide. Our input variable is project funding 30% and project staffing 68%, for example, right? So this is similar. So U1 input 1 is 8 and U2 is 4. Okay, and then your S1 low of U1 is 0.2. Okay, the degree of membership of low is 0.2 and degree of membership of S2 low is 0.5. So our first rule result 0.2. Okay, let me just draw this for you so that you can understand it better here. Okay, so from here you know that your rule number 1 is S1 low and S2 low, then y is a function, right? It's a function. This is the function. This is your function here. Okay, R2 S2 low, sorry, S2 is high, right? S2 high and S1, sorry, this one is S1 high and S2 high. Then y is another function. This is function 1, this is function 2. Okay, so what is the function here? 0.5u 1 plus 0.2 u2. This one is the u1 plus u2. Okay, right, so this is your rule. These are your rule. Okay, so from the given question, you know that the degree of membership of low, S1 low, is equal to 0.2. This is the information that has been given. Yeah? And then degree of membership of S1 high is equal to 0.8. Degree of membership S2 low is equal to 0.5. Okay, here, take a look at here, 0.5. And degree of membership S2 high is equal to 0.33. Okay, then you were also given the input variable, that is U1 is 8 and U2 is equal to 4. So using the Mamdani Sugeno, Takagi-Sugeno rule evaluation and defuzzification process, you have to find the crease value or the weighted average. So what you have to do is you have to draw the fuzzy rule graph. Okay, so the rule evaluation graph will be like this. Okay. So from your given graph, okay, from the given graph, what would be the graph of rule 1? Okay, you know that if it's stated here that S1 is low. So which graph are you going to plot here? So it will be this one with low. So this is S1, right? And okay, S2 is low. So how is the second graph? Okay, the second graph would be like this, low. Okay, so it will be this one. Okay, S2 low. Then, okay, what about the spike? Okay, how are we going to draw the spike here? Okay, it is based on your mathematical function here. So we know that the mathematical function will be what they call that substituted with the value of your input variable, right? So for the first output, okay, for the first y1, okay, so you are going to substitute 8 into u1, okay, 4 into u2, okay. So 0.5 times 8 plus 0.2 times 4. So what would be the answer? It is 0 equal to 4.8. Okay, so our first spike would be around somewhere around here, 4.8. Okay, and then what about the value of the degree of membership here? Okay, how are we going to know the degree of membership here? Okay, that is why in here it said that y1 is the degree of membership is 0.2, but then it does not show how the calculation is being made. Okay, so what we are going to do is we have to take a look at the value of our degree of membership given here. Okay, so we know that the degree of membership of S1 low is 0.2. Okay, 0.2, and then S2 low is 0.5, right? So if you compare the first graph and the second graph with n, okay, so if you use n, what would be the value here? You are going to take the minimum value. So that is why you are going to draw 0.2 as the value of degree of membership here. So this is 0.2. So the spike will be go up till 0.2. Okay. Right, it must be a spike, yeah. Okay, you can draw it with a ruler later on. Okay, next is we will take a look at the second rule, rule number 2. What is rule number 2? S1 is high and S2 is high, then there's another function, right? Okay, so what would be the graph here? S2 high would be like this. Okay, S1 high. Okay, and then n, right? N, S2 high. Okay, S2 high somewhere around here. High. So what would be the value of the spike here? Okay, the value of universe of this course is based on the mathematical function here. So we will do it again. So 8 will be substitute into u1, 4 will be substitute into u2. So 8 plus 4 is equal to 12. So you know that 8 plus 4 is equal to 12. So your y2 is equal to 12. This is y1 is equal to 4.8, y2 is 12. So the next spike would be on where? On the second one, that is 12. So the first one is at 4.8 with how many value? 0.2 here, somewhere around here, 0.2. And then 12 here, okay, 12. How are we going to calculate the degree of membership of this spike? Okay, So from here, we know that from the given question, from the given information of the question, we know that S1 high is 0.8 and S2 high is 0.33. Okay, S1 high is 0.8. So where is it? Is it, okay, somewhere around here? Okay, I will say it is somewhere around here, 0.8. And then for S2 high, 0.33. Okay, 0.33 somewhere around here, right? Okay, so if we compare this, which one would be the result of your output? Okay, the degree of membership. So you use N, so we are going to use minimum. Compare 0.8 with 0.33, so it will be 0.33 here. Right, so your spike for Y2 is at 0.33 here. Okay, so this is your output. Okay, then only we are going to calculate the weighted average. Okay, then only we are going to calculate the weighted average. How are we going to calculate the WA? WA is based on the output, okay, the output graph here, okay. So we know that this is 0.2, okay, the membership is 0.2 and the spike is at 4.8 plus 0.3 times 112, okay. So WA would equal to 0.2 times 4.8 plus, okay, 0.33 times, okay, 33 times 12, okay, over, okay, over what? Over the degree of membership for each spike, yeah, 0.2 plus 0.33 because you only have 2 spike, okay. So from there, what would be your weighted average? Equal to 9.36. So it will be somewhere around here, 9.36. So your result of Y is 9.36. Okay, if you are given U1 is 8, U2 is 4, then your result would be, your output is 9.36. So that is how we are going to do the Takagi Sugeno example, right? Thank you, everyone. Okay, before I say thank you, sorry, we have another one that is on the summary. Okay, so you have 2 types of what we call as we have 2 types of method, okay, on falsification. One would be Mamdani and another one is Sugeno, okay. So in Mamdani method is widely accepted for capturing expert knowledge, okay. Usually in expert knowledge, it will allow us to describe more the expertise in more intuitive or more human-like manner. So that is why we are going to draw the fuzzy graph, okay. However, Mamdani type fuzzy inference entails a substantial computational burden because we are going to use the COG, and then for every calculation of COG, we are going to draw, can you imagine the graph again? Okay, let me draw it, okay. If you imagine the graph here, okay, for example, this is the clipping, okay, it's like this. So you have to calculate for every the universe of discourse here, okay, universe of discourse, you have to calculate the value of COG, okay. So this is why we say it is a substantial computational burden. On the other hand, Sugeno methods is a computationally effective and works well with optimization and adaptive techniques, which makes it very attractive in control problem, particularly in dynamic non-linear systems. So this is a popular question where in final year it will ask state the differences between Mamdani or Sugeno. Okay. In Takagi Sugeno method, it can use machine learning system for determining the parameters. EA can also be used to evolve the system structure and parameters. And it is useful for modeling very complex system, and it also can incorporate objective system performance data. So we have seen all of the fuzzy inference process, that is fuzzification. Based on our real world data, we have to do fuzzification. Then we do the rule evaluation, defuzzification, then only we have the output, the crisp output back. Okay, so we will do a tutorial, okay, next week. I will give you a question first, so you have to take a look at it, and then we will discuss them together in our next class. Okay, thank you everyone. If you have any question, you may ask me in WhatsApp group, or you can DM me. Thank you everyone. Assalamualaikum.